Yeah, let me start sharing screen. Just let me know if you can see my screen. In the last class, we were talking about exception handling. Yeah, maybe we'll finish that today. And then we move to the new topic, multi-threading. So that is what we are talking in last class. So exception handling, we had discussed till this example, I believe. Uh, I have to change to recent projects. Yeah, probably this one. Yeah, we are talking about OOP, object-oriented programming. That is, where is OOP here? They have something with name OOP. It's okay. For now, I create one new Python package. What shall I say? Just name this here as exceptions. Okay. In the last class, we have discussed something. What is that? Try with multiple exceptions. That would be definitely a needed scenario because sometimes people might ask that in interviews. And the example we are seeing is this something like, yeah, kind of this one. Try with multiple yeah, yes, this one. So we can copy and paste this for a while. And we can have this finally as well. Today, we will take uh, one useful scenario so that gives you an idea. So try with multiple exceptions. And this is the example we can take here. Okay. So we have both index error and zero division error. We are talking about it. And we also added one more thing like parent as exception as a and every time you can just pass. You don't need bracket for one exception. So you can just take like this, something like E. Okay. And here also you don't need a bracket. You can simply say index has some E, something like this. We just discussed this example in last class. And then if you want, you can print that by error, it's showing error expected colon. Okay, I got it.
Yeah, is missing.
Yeah. So now if you want, you can just print this, uh, all this exception summary as well. Okay, just print this. So this is a important rule here is I had already discussed. What is that? This I will just give you a little deeper discussion in today's session about the exception hierarchy, how they are, which is bigger, which is smaller, when which kind of exception block should be kept at bottom, which kind of exception block should be at the top of exception hierarchy. All this we discussed today. Whatever we are discussing is very useful if you want to do any certification exams. All this. Okay. Now let me run this. Yeah, this is working as expected. Fine, no problem. Now this is the idea of what is that? Try with multiple exceptions. And of course, if you want, you can add finally block. But for this scenario, we don't have adding finally doesn't have a big value here because we are not doing any closing operations like for closing files or closing sockets or closing network. We are not doing any such kind of closing operations. So finally is needed in such cases. Okay, I'll talk about all that scenarios. So before this, I would like to show you exception hierarchy. What are all exceptions we have and how that hierarchy is in Python, all that. Let us see that in today's session. Okay. So now just see exception hierarchy in Python. Okay. You take built-in exceptions and go to the bottom, somewhere at the bottom. Yeah, this one, this is important for us. See, this is the hierarchy for built-in exceptions. See, for in most of the times in exception handling, we have already existing or predefined exceptions. We don't need to worry much about user defined, but user defined is also equally important. Of course, we see that. But these are all built-in exceptions, and actually the base class of all exceptions is base exception. From base exception, all these exceptions are inherited, including exception class. You see, I'm using exception, right? This is a subclass of base exception. Right? If it is Java, we have something like throwable. From throwable, all these exceptions are inherited. That both exceptions and errors are inherited. Here, everything is inherited from base exception. Even exception is also subclass of base exception. And remaining all exceptions we use in the program are subclass of exceptions. You can see here. Arithmetic error, assertion error. See, there are so many. If you look at this, at least you see handful of exceptions that raised in our code. You can see type error, value error. You keep seeing these errors very frequently in the code. Yes, right, friends. Type error, if you see attribute error, there is one more. We very frequently see, you can see this attribute error, right? So zero division error, you can see this. Sometimes overflow error and floating point error. Sometimes, okay. Index error, you can see here. Key error. So we see these very frequently. This one zero division error we generally see. Attribute error, index error, key error, and then module not found error. And then I'll just show you what we regularly see in our code. So in files related, we get these kinds. What is that? File not found error sometimes. Okay. And then also we also see something like syntax errors, indentation error. This is quite common error we see. Type error, value error. Okay, and then sometimes we see this import warning. Okay, these things. So finally, let's just conclude here. These are all exceptions. Every exception you see here, if you see a lot bunch of exceptions, predefined exceptions, all these are inherited from a superclass exception. And this exception is inherited from base, that is fine. But this is important for us. Now the point is, I'll just show you with a small diagram. This is very important, friends. If you are doing any certification exams, these scenarios definitely help you. Exceptions are like this. Suppose you take a example of what is that exception. So you have zero division error, suppose. Okay. So you have zero division error. Okay. And uh, you have one more error is Let me define one more. One more is index error. Okay, index error. And one more is exception. Assume that these are the three exceptions I'm taking just to show you. This is very important. Exception. Okay. In development, if you just use just a try and accept with exception, that is enough. But all this is needed if you want to do any exams, right? Give any exam on Python or something. Okay, day before yesterday, I was doing one internal exam. Okay, in our office. So I came across many of these scenarios. Okay, this might be helpful for you. Now, how these exceptions are? See here, friends. So you see, zero division error is a subclass of this one, or arithmetic error. Similarly, index error is it is a subclass of lookup, lookup which is subclass of exception. You know, inheritance and all that hierarchy, right? Now, zero division and index are both are two different errors at same level. We can assume that both are at same level. Now, assume that these are like this small buckets. Zero division error is one bucket, right? Which is actually a small bucket. Even index error is also a small bucket. Index error is also a small bucket. And exception is little bigger bucket because it is super class, right? You can just remember like this, little bigger bucket. I'm just trying like this. Okay. Now, what is it? You have a code on top of here. You have a try block. Inside try, you have something. Okay. You have some kind of risky statements. So what happens here is simple. If any exception is raised in try, suppose zero division error is raised, then it is thrown to this zero division error. Okay, this is the zero division error, and this is index error. And finally, last one is exception. If exception is raised in try block, suppose if zero division error is, then it is thrown to this one. Suppose if the exception raised is index error, then it is thrown to this one. Else remaining all are thrown to this one, this bucket. Now suppose you do one thing, just flip all this. You put this big bucket in the beginning itself. Suppose you put exception as the first argument or a first block, and then you have these small buckets. See, just a quick thing to understand this. Now you have a try block here, right? I have a try block on top of all this, and some kind of risky statements are there. Now I have a zero division error here. What is it? I have a zero division error in try block. Then the exception from try is thrown to catch block. Sorry, this except block. Then who will handle that? This exception block will just hold that exception or catch that exception. Whatever is thrown from try, everything that is thrown is caught at this level itself if you put exception block in the at the first place. These two are just namesake, they will be there, they will never be used. Right? These are unreachable blocks. If you have exception as a first parameter in that exception blocks, you got it right, friends. It is like having a big bucket before small buckets. What happens? Everything comes will get into this bucket only, and these small buckets never get a chance. So this is why you have to be careful while declaring this exception blocks. Now, finally, you should be very clear with this example. What is that? When you are creating exception blocks, make sure, what is it, friends? You keep the hierarchy should be what? Smallest exception should be at the top. And that has to keep increasing when you go towards bottom. And vice versa is not going to have big impact. It doesn't add any much value to the small exceptions. You got it right, friends. So what is the hierarchy? This is the hierarchy we have to follow. Suppose you put this at the beginning itself. Suppose you put this. I had discussed this just this thing. Like in last class, we have a quick discussion, just showing you a little bit in detail in today's session. Now you put exception here. Then there is no point of having these two blocks. There is no use for the other two blocks because they never get a chance for execution. These two becomes unreachable code because whatever exception that is raised in try, exception will catch it. Then what is there is no point of having this except block, this except block. These are unreachable codes. You can remove them, right? And this exception is enough to handle any exception raised in try block. If you run this will also show you the similar output. But if we are creating multiple exceptions, make sure you follow this proper hierarchy. Follow the rule. What is that? Small exceptions at the top, and then the bigger exceptions should be at the bottom. That is the rule we should follow if you want every except block to be executed, to be given a chance for execution. So that is the idea, friends. So this program, again, this example. So I hope I shared this example also with you in yesterday's session or day before yesterday. Now I'm removing all this. One more scenario. So what is this scenario? This scenario is one try block handling all exceptions. What is it? One try block handling, sorry, one except block. Maybe I should not say try, one except block. We have just one try always, but we can have many except blocks. But to handle any exception thrown from try block, we can have one except block. That is enough. One except block handling many exceptions. What is the simple thing here? Simple thing is very, what is it, friends? If you just declare except with exception, or if you see in the hierarchy, or with base exception, you can see here, right? With base exception or exception, then this exception can handle any of these exceptions thrown from try block. So then what is that I should do here? Simply I should put my parameter here as a exception. You got it right there. So that's all. This is a try block, or this is an except block which handles any exception thrown from try. Right. So this is one more scenario. Now you can run and test also, no problem. You don't need remaining two as well. What is that? An except with the zero division error and an except with the index error. You don't need those two as well, friends. Okay. So that is the idea. So I'll just share this with you. This is an except handling all exceptions. Okay. Next one is insert. Insert. Next after this, I think we are simple. This is the idea. Next important thing is exception types. So this is when you have, we have generally, now we had discussed exception hierarchy. So this is the built-in exception hierarchy. So finally, just remember. So you can get it from this particular place, all this hierarchy of exceptions. If you want, I'll just share this link with you. Maybe for reference, you can use it to see exception hierarchy in case if you have any doubts. Okay, fine. Next after that. So now types of exceptions. Generally, we have two types of exceptions. If you see here, these are all built-in exceptions. All these are built-in, predefined exceptions, right? So that is one thing. Second thing, in development, always built-in exceptions are not sufficient. You got it right, friends. What is not sufficient? Built-in exceptions are not sufficient. Sometimes we need user-defined exceptions. Got it? We have to create our own exceptions or custom exceptions, right? So if you when you are doing a big development, then apart from built-in exceptions we need to define our own exceptions. This is also very important one. right? So built-in exceptions by now we know this type error, name error, index error, zero division error, attribute error. We have seen so many. So whenever you see that runtime errors, you should handle that. Got it right, friends. So also one more thing, when you talk about errors, I think I should have added this in the beginning, right? Generally, we have what is that? Three types of errors here. One is types of errors. One is syntax errors. That is one thing. Second thing, runtime. These are dangerous. This is what we should handle, not syntax errors or logic errors. Runtime error means it's an error which occurs at the time of executing program, and these errors terminate your program abnormally. You got it right. So we have to handle these kind of exceptions, friends. And logic error. Logical error doesn't provide expected output. So you do instead of addition, you do subtraction, or instead of subtraction, you do multiplication or product. So these are all these errors lead to logic errors. You don't get expected output. Okay, that is okay. But it would this don't break the program and syntax errors we don't have issue because in the beginning itself while testing itself this will break. But this one is dangerous. So you have to handle this. Now you know already how to handle runtime errors. Right? What is that you should do? Use try and except blocks. Okay, that is one thing. Next, one more scenario. What is that? Just one small scenario I would like to quickly discuss. Not one scenario, two scenarios. So what are those scenarios? Let me just stop here. So let me put this here. Okay, let me have this. Suppose in one except block, I want multiple exceptions. Suppose you take this, no need of two this thing here. What is that you can do? You can add multiple exceptions in one except block like this with the comma separated. Okay. So maybe if you want, you can add some more here. Suppose you can also add something like okay. Even if you want, you can put exception here, and then you can say like this as well. You can remove all this. You don't need this. This is one more style of syntax. Suppose if you see these kind of syntaxes, you don't need to just think that this is something new for us. We can also have multiple exceptions in one except block, comma separated like this within these brackets. Got it right, friends? So this is the idea. Now run this. Now let's run this now. Now you can see. Got it right. So which one is so which exception is raised here? Index out. So probably this should get executed. This might execute at the end. Otherwise, just remove it. Just having that idea about this syntax as well. I'm just showing this example. Now you can also have an except with multiple exceptions, comma separated like this. Okay, right click run this. We are seeing all different possible scenarios. If you ask me, I generally just I always use this. What is it? I put something like exception as a and just I call logger on this actually instead of printing. Right, in development we need to call logging. We'll see logging topic as well after in these discussions. So I said something like e dot or something. I call a logging on this. That's all. Got it right. This is how I create. I handle exceptions in my code. Okay, I generally don't go for zero or zero division error or index error or anything specific, but I always keep a block like this if it is me. But I do have idea, like if at a subclass level, if we should declare exceptions, yeah, I am fine with that as well. Because I know the hierarchy here. Okay, fine. This is okay. I'm just sharing another style where if you want to handle multiple exceptions in one except block, so this is helpful, friends. This is the syntax for that. I'm just sharing this as well. Well, let me share this to you. So let me put this in the this one. And next one, another scenario is using finally properly. What do you do? Suppose you have a file operation. Suppose you see here, you are just doing a file operation. Okay. So you can remove all this. Now you don't need these things. I put exception from now onwards for our exception handling, exception as is something. Now you do a file operation, some fp equal to, okay, open of some abc.txt. If you want, you can pass full path, absolute path. I'm just saying a simple relative path here, and then I'm just saying a simple write operation, and then fp dot write. Okay, I'm just saying hi, hello, or something. Okay, enough. That is enough for testing. And under try put except as exception. This is enough. Now we have open a file, right? When you open a file, we have to close file. Then when do you close that? We have to close that in the fp dot close parenthesis. Where should I have to close it under in the finally block? So this is how we should use finally. Where finally is more used is in these kind of file operations or database connections or network connections. So finally, this one you can see here. What is it? We did a file operation in try. Probably, I doubt if this becomes a local. We'll see. If you get error here, just put this open statement outside try. Make it a global statement. That should be fine. Okay. Now run this. So it's working fine. No issues. No error or anything. FP has access. Okay. Finally, you do one thing. Also, just add a print here. Write successful. Okay, just write success. Just for seeing something in the output. Right click, run this. Okay, write success. Similarly, you can see the file created here. Okay, open this. You have hello here. So we are fine, totally fine. And when you do this file operations, this closing file should happen in the finally block. And not only this, any any closing operations should go into finally block. Are you following, friends? This is the idea. So this is the a real-time example of finally block. So when you have finally, this is how we should use finally, right? So finally, the what is the conclusion, friends, or summary? Try and accept are always used because even in my automations or development I don't keep finally every time because wherever that file operations are database connections are this one. What else, friends? One more is network connections are involved. In such cases, I try to have this. Okay, so I'm sharing this with you. Let me put this with you. But in other cases, you don't need. I'm not saying that if you put finally, nothing harm comes. But having just finally doesn't have big impact. That's my point. Okay, uh, this is the idea, friends. Okay, got it right. So this is the real time example or a best example to understand the exact purpose of finally here. Okay. Now after this, before I jump to user defined exceptions, one more scenario that helps for interviews or exams. Suppose you see, friends, I can remove exception block. I mean except block. This is very important for interviews, okay? Sorry, even for exams, and I mean certification exams. This scenario, you can have a try block without except by having finally. But if only try doesn't do anything, friends, there is no use for that and it leads to error. Try should be either followed by except or finally. Ideally, except should be there. Suppose syntactically, we don't need to have except, but we can have finally. Okay, now you remove this. This file thing is clear, right? All of you are clear. When should we should use finally and simple example to understand a scenario of the real use of finally. Now take a small example. Do one thing. You try to raise a division error directly. Right? Put finally after that. You can close this. So you can simply say finally. So finally called. Okay, this is fine. Now right click and run this. Now you can see syntactically this is fine. When suppose if you just divide one by one or something, it is okay. No error, nothing. This is fine. This is very important, friends. Okay, this is syntactically no issues. You don't get any syntax error or anything. But even though this is okay syntactically, but if any exception raised, see, just run this. If you run this, there is a no doubt when we divide something by zero, we have a division error. No doubt about that. When you have division error, then what happens? Exception is raised in try block. Then who should handle that? Definitely, we should have except block, right? So, but point is, in this program, do we have except? We don't have except. Then what happens, sir? So run this now. Exception still is thrown. Finally is called, but what is the use? Nothing. The purpose of finally is generally to do cleanup operations, that closing operations. Point is, you can have a finally with try block. This is syntactically valid, but exception if exception is raised, then finally cannot handle exception. Always it is the except who handles exceptions. And this kind of questions you might see in certification exams. They will, if you don't know this scenario, you might think that this is not valid or you might answer it wrong or something. So having knowing this is important. But point is, this doesn't have any impact if exception is raised. That is what I want you all of you to know, friends. But syntactically, it is okay. Right. Finally, this is one more scenario. What is it? This is useful for interviews or some certification exams. Okay. Now let me share this with you. Next, finally, we are coming to the most important part in exceptions. What is it? Of course, the topic is simple. I don't think we have any difficulty there. It's a simple topic, friends. What is that? So sorry. What is that? We user defined exceptions. Creating your own exceptions, friends. Exceptions created by the developer are creating. So far, we have seen like yesterday and last class and today's class, we have observed so many examples. We have seen numerous errors so far from the start of Python. So if we look at the hierarchy also, many exceptions seems familiar for us. What is that? This zero division, this attribute, this what else? Key error, index error. We have seen these examples many times in our code. The syntax errors, indentation, all this. Okay, type error, value error. We see such errors very frequently. These are not new for us. Exceptions are not new for us, but we got a little bit more better understanding now how to handle them. Right? That is fine. But what is the point here? But that is not alone is enough. What is not alone is enough? Built-in exceptions. We need to create custom exceptions in development. That is very important. Got it right, friends? Sir? So when you are doing a very, creating a big project, developing a big project, then creating custom exceptions is important. And they are created by the developer, something like it. These are simple examples: age error, insufficient funds errors. Otherwise, it's up to you. Any error, the way we create is same. Just we change that name. That's all. And this is very simple. These steps are very simple to create your own exceptions. Now you are good with too many things like exception hierarchies, inheritance, about constructors, about constructor calling from subclass to superclass. As you are familiar with so many things, this is not difficult for you to create a built-in customized exception, right? So finally, what are the steps we should do to create customized exception? Simple. If we should create a user-defined exception, a custom exception, it has to be inherited from a built-in exception. So you see the hierarchy right here. These are all. Better inherit your exception from exception class. If you want to behave that as exception, or if your exception should be only arithmetic error, just inherit it from arithmetic error. You got it right. Or if you want to make it as just only, what is it? Only a value error. Inherit it from value error class. You got it right. How powerful you want to make your exceptions? Simple. It depends on its superclass, right? So superclass decides the power of subclass here. That's all simple. So why? Because here in this program, how to create custom exception? If we should create custom exception, we have to inherit it from some built-in class, right? Better always inherit from the supermost class exception or base exception. That is the best thing, right? So that is the idea. So what do you do right now? That is one thing. Step one. What are the steps here? One is inherit your class from superclass exception. Then what is that you have to do? Then you have to explicitly raise these exceptions. Here are the steps. Let's do one thing. These are the steps. Step one, create an exception class. How do you create it? So we have to inherit it from some built-in. Better inherit it from exception class. So it's so simple. See, just so that class name exception just pass. You don't need even anything inside that any code inside that class. Just create that class name and put pass. That is enough. Second thing, step two, you should raise that exception. Whenever you need an exception, custom exception, you should explicitly raise it. Got it right? We will see that with a simple example. So for that, you have to, what is that? Include this rise keyword. You can see here, raise that exception class name. What is this rise keyword? It is like throw keyword in C++ or in Java or C Sharp. So far, what is that? We never thrown exception from try to catch or accept. Sorry, let me just put here the actual code. In this program, we didn't explicitly throw any exception object from try block to accept block. If exception is raised in try block, it is automatically thrown to accept block because they are all built-in exceptions. Got it right? They are built-in. So they are automatically thrown from try block to accept block. But if it is user defined, once you create your own exception, if you want to raise user defined exceptions, you have to explicitly throw them or raise them with raise keyword here. For that, just you need to put in try block that raise, use this is the syntax, raise that exception name. That's all. Got it right? That's example, raise that this one. If you see one example, you just feel it's so simple. You got it right. If you look at this also, it is so simple to understand. These are the two steps you should follow. Okay, step one, create exception. Step two, whenever you need that scenario of raising custom exceptions, call that there. That's all. Only thing here, if you look at the syntax of exception, You create any exception, just only the class name changes. Other than that, there is no big difference. Got it right? Let's do one thing. Let's create a simple scenario, balance check and raise insufficient error. You see this very frequently. Where do you see this, friends? Sir? Where you see? You see this in ATM. Let us create a scenario of what is that insufficient scenario. Okay. So what do you do now? You do one thing. You create one class name here. So you create this as a custom exception. Okay. User define anything. Simply say class insufficient. Step one, you should create always, if you want to create user defined exceptions, create a user defined exception inherited from where? From a built-in class. Recommended generally, just go for exception. You don't need to confuse much. Okay, class. Okay, I'm just creating insufficient funds just to do any transaction. In that transactions, if you don't have sufficient money, then we should raise this insufficient funds error. Okay, close this and just say pass. You don't need anything here. Okay, that's all. Now after that, what is this? If you want, you can just leave it like this, and you can what you can do, you can create it as a module and leave it like this. Now, if you want, create one more. What is that? Exception, custom exception test. Okay. Now what is that I am doing here? I am doing I am taking a balance. Okay. BALANC balance equal to some assigning balance first. Some 1 lakh. Okay, 5 zeros, right? Yeah. Now I want to do a withdrawal. What is that? Withdrawal. Whenever you want to do any withdraw from account, right? What is that you should do? You have to check if your balance is greater than that amount, right? So what is that you do? Maybe if you want, you can define a method otherwise. Okay, withdrawal. Okay, DEF. Okay, so you can just write account underscore withdrawal WL. Then you can pass here amount here. Okay, or you can pass balance here to balance check here. And then what do you do here? Simple. If you know you need some amount, right? So also you pass one more parameter here. How much you want to withdraw balance, and then amount to withdraw, right? So if balance greater than amount, okay. So what do we do if balance, sorry, less than amount? So you are asking for some amount and you have some balance, right? If balance is less than that amount, you should throw error. How do you throw error? Try, colon, then you have to say raise. If it is less than, then you have to raise. So because you don't have sufficient balance, raise that insufficient funds error. Excuse me, friends. You can see here, this is automatically importing that thing here. What is that thing? It is importing package and then that module and then that class as well. See, from it's importing all that. Can you see here? Because it is in a different module, right? If it is in the same module, it is fine. Same file. But insufficient funds error we created here under custom exception, which is present in this particular directory. So that package dot that module, and it is importing this one. Got it right now? Now we have to raise insufficient funds error, then put except. You can simply say if you want, you can put exception, no problem. Better we are testing here, right? So you put insufficient funds error. But instead of this, always you can have exception. Just an FYI for all of you friends. Okay. Finally, what? You can just print E here. That is enough. And finally, what? So that is the idea. So if balance is not sufficient, you should test that and raise that error. And finally, suppose if you have sufficient balance, then you can simply say transaction success. Simply say print. What is this? Transaction. Okay, success. So this is how you can create your own exceptions. Okay, and then you can use that in your code. You can invoke. It means call that in your code like this. Okay. So finally, what transaction success? So we define that in this method. Now, what do you do? First, you can take a variable amount. So just say float of, okay, just input, enter amount to be withdrawn. Amount to be withdrawn. Okay. So this is one thing. Fine. Then what is that? Once we have amount and also balance in place, we have already balance set with something here. Okay, balance is set to some 1 lakh. That is your balance in the account. Now what do you do? Call account withdrawal method and pass what? Sorry, friends. Pass balance. Common. You don't need to pass this. This is a global variable, no need, but just for as a process I am passing. That's all. Okay, balance comma amount. Pass that these two to that. If you want, you can add more logic in the balance method. Okay. So what is that? If balance is less than amount, then we should raise error, no doubt. So we don't know what is the amount we are asking here because it is dynamic input. We are reading it from keyboard. So until we enter, we don't know how much amount we are entering. Based on that, the error comes. Okay, finally, this is the idea. So now what do we do? Let's try to run this and test the code. Right click, run this, enter amount to be withdrawn. Suppose it is 20,000 I am passing. Maybe you can add a logic here, small logic. What is that? Okay. Now after doing withdraw, what is the balance? Balance equal to balance minus remaining balance, we can say minus amount. So we can say remaining balance. Okay. So here transaction successful. Okay. Amount withdrawn is what? Right. We can just add few things. What is that? One or two statements. What is that? Amount withdrawn is one. Okay, you can just add here amount withdrawn. Just a simple logic, that's all. These are all not something really difficult to understand. Okay, comma, you can just put what friends? Print amount. And second thing, same another print here. Just add balance, remaining balance. I want to see balance as well. But you can create separate methods for all this. That makes more sense, but it's okay for now. Remaining balance. Okay. So now finally what we do, you can just print balance here after doing withdrawal. Now run this and now you try to enter something here. Suppose you pass 20,000. So this is fine. Amount withdrawn is 20,000. Remaining balance should be 80,000. So I should print what? Remaining balance, not this. Okay, now run this. Some 20,000. Now this is perfect. Transaction success. Amount withdrawn is that, remaining balance is this. Suppose you do one thing, you give some 1,10,000. Okay. Now you run this. How much we have balance here? We have 1 lakh, but I am trying to input 1,10,000. Even if you just add more than 1 rupee also, it leads to error. Okay. So now run this. Sorry, 1,10,000. Enter. Now finally what? So there is some raise insufficient error. There is exceptions must be derived from base class. Okay, sorry. See, what is the missing here? I didn't inherit this from exception. That is the error. Why it's throwing that? Because even though we created custom exception, just we defined a class name, but failed to inherit. At least I didn't inherit it from supermost built-in exception class. So that is the error. Now I fixed this. Okay, now we can run it, test it happily without issue. So pass 1,10,000 here. Okay, one more zero. That should be perfect. Now you can see this. So exception definitely raised. Okay, but there is no summary. You can just add a summary here. What is that summary? So insufficient funds. In this constructor call, you should add that. Okay, balance is, or rather simply say insufficient funds. You see this even in that slip as well, right? When you try to do that withdrawal sometimes and you get that insufficient funds. Just add this here so that this print can print that. You don't need to see something empty in the output. Now run it one more time. So finally what, some 1 lakh. Okay. 1 lakh, 1 rupee I'm passing. Now you can see this insufficient funds. Right? If you want some exception summary, that then you have to pass it here in the constructor. Then that is again we can see in the output. You got it right. So while calling this raising exception, there you have to pass this exception summary, friends. So finally, what is happening here? So if you look at the execution flow, let me debug it. It's still taking time. Okay, let me pass some amount here. 1 lakh 1,000. Okay, enter. Now this one is started. Step into, you can see here. This is the amount, this is the balance. Definitely balance is less than amount. That is true. Then we are raising, you can see here, we are explicitly raising exception. This won't raise by itself. These custom exceptions, see friends, based on scenario and condition, we have to throw or raise custom exceptions. Got it right, friends? We have to throw or raise custom exceptions. Now you see, step over, come to the try, step over, come to raise. Then here, this exception, once this condition is true, then we should raise this exception. That sufficient funds are not sufficient. So again, step over, you can see immediately from there the control jump to accept. That accept block handles this exception thrown from try, and it prints that you can see that insufficient funds. Got it right? Finally, it comes to where it comes to the color. This is the execution flow, friends. Got it right? Point is here, difference between built-in and custom exception is, so built-in exceptions are automatically thrown or are raised and thrown to accept. But custom exceptions, we must raise them like this. And also this summary you should pass if you want to see something in the output. Sorry. Got it right, friends? Something like I'm just passing some 10,000 should be fine. This is the idea. Understood? So finally, what friends? I'm just sharing this code with you. Got it right? All important steps. Step one, inherit your class from built-in exception. See, to simplify this, you can just copy this. I just put it in a different file. That is what we do. All exceptions we create and keep it one file in one file. But here, if you want, you can create that exception directly in this module itself. You don't need to import or something. Okay. For testing purpose, I am keeping here itself so that it's easy for you to test. Now you don't need to import any module. Just skip that part. Okay. Right click. Now run this. Same output. You don't see big difference. Okay. You can see that this is working. This is a positive scenario. Maybe if you want to test with a negative scenario, run it and pass it. Okay. And enter. This is a negative scenario. And we tested both scenarios and both are working fine without any issue. We are fine there. Got it right, friends? So this is all about exception handling. I think we try to cover as much as possible. I'm just sharing this with you, friends. Let me share this with you. Clear, right? So maybe if you want, you can also have nested exceptions. Try and try, and also you can have try except in except block as well, like that. That is fine. Okay, syntactically, just to see if you want to see something, then we can have all that. But like this, you can see here. What is that? You can have a try except finally inside try block. Also, you can have try except finally again in except block. If you want to, you can have try except finally inside a finally block as well. So this is nested blocks. We can have like this. This week quite regularly we implement, not inside except and finally, but most of the time we try to have it in try block itself, nested tries. Okay. Sometimes in finally we might declare that. In except mostly it is very rare you follow this scenario. And this is also possible. This syntax is also a valid syntax. And this is again helpful for certification exams. If you want to do Python certification, all these are useful, friends. Whatever we are discussing covers too many things there. You got it right. So that is the idea, finally, friends. Got it? So with this, we close successfully exception handling. Tomorrow we come up with one more interesting topic, that is multi-threading. I think I have a question from one of our friends as well. We'll try to discuss that. Okay. And stop recording.